Hello everyone. I think I am repeating this video for the third time. In this tutorial, we are going to learn how to derive that formula used to calculate the area of a cycle, which is pi r squared. So if you are a calculus student, stick to the end. Assuming we have a cycle, we have learned that the area is given by the formula pi r squared, right? So we would like to derive this important formula. We have learned that the circumference of a cycle, which is the same thing as the perimeter, right? The total length around a given figure. Circumference is equal to 2 pi r. But this is our subject of discussion. If we can cut, because remember we have a center here, and from center to any part is called the radius, right? So this is a radius. If we can cut this cycle into tiny pieces of sectors, what is a sector? If you have two radii, you have a sector, right? This is a sector. This, let me shade it. This shaded region is called the sector. So if you can fit in multiple tiny sectors into a rectangle, you'll be able to derive this important formula, which is pi r squared. What do I mean? If I should cut this sector and place it here, but we are going to cut tiny sectors so that we could have something like this. This is one sector, right? Then I can place another one here. Then I can place another one here. Another one here. But make sure they are as tiny as possible. The reason why we have some gaps, you can see we have some gaps, is because the sector is not as tiny as possible. You know, it's only a computer can do that work. All right. So the total length here from this end and plus this end will give us the total circumference. Because look at the arc here. This arc, we have multiple arcs round. So all these arcs together with this one down here will give us what? 2 pi r. So if you divide it by 2, this will be pi r, and this one will be pi r. And remember, from the center to the part of the circumference is a radius. And this is the beginning of the leg of this sector. This is where it begins, and this is where it ends. So this is a radius, and this is a rectangle. So if you multiply the length by the width, you're going to get the area, right? So area is equal to pi r, which is the length, multiplied by the breadth or the width, which is also r. This together will give us pi r squared. But you can only do this if you're able to fit in multiple tiny sectors of a cycle, of that particular cycle, which I believe you cannot do that. Only computer can do that. But let us derive this formula on a Cartesian plane. If you have a cycle on a Cartesian plane, this cycle is not that good. Let me draw another one. All right, manageable. So this is a cycle on Cartesian plane. This is y-axis, and this is x-axis, right? And you should know that this is the center. Therefore, from this end to this end is a radius. So this is a radius. And any other point from this center to the part of the circumference is a radius. So how can we find the total surface area of this figure on a Cartesian plane? If from the center to this part is r, then from the center backward here will be negative r. Remember, Cartesian plane, this is positive x-axis and we have negative x-axis. So it is going to be the integral from this point to this point, negative r to r, of that function used to construct this cycle on grids, which is y, with respect to x. If you decide to go like this, and if you go from bottom to the top, it is going to be dx. So what is this y? Y is the equation of this cycle, which we know is what? X squared plus y squared equal to r squared. So our main goal is to make y the subject. And if you don't know where we got this equation, you can draw a right angle triangle on these grids. You see this is r, this is a value of x, this is a value of y. And according to Pythagoras, it stated that r squared is equal to x squared plus y squared, which is here, with an acute angle right here, which we can call theta. So therefore, we can make y squared the subject here, or y, simply because we have y here. So y squared is equal to r squared minus x squared. Then you can take square root of both sides. You have y equal to plus or minus the square root of what? R squared minus x squared. Why do we have plus or minus? Plus the square root of r squared minus x squared will only give us the semicircle here from this upper direction. And the negative version will give us this one. And since it is symmetrical, I think we can use the positive version, then we multiply by 2. Because if you take the positive version, it is only going to give you the area of the semicircle at the top. By multiplying by 2, since it is symmetrical, the same areas, you're going to get the total surface area. So first of all, I would like to use the positive version. Let us substitute it in place of y. So this is the integral from negative r to r of what? The square root of r squared minus x squared dx. Again, if we like, instead of integrating this function from negative r to r, why not integrate it from 0 to r? Because it is also symmetrical. The area here in the first quadrant is exactly the same with this one. So, okay, sorry, I forgot to multiply by 2. That is for the semicircle above and below. Now, if we decide to integrate it from 0 to r, then we have to multiply by 4 because we have 4 quadrants and all of them are identicals. So this is also equal to 4 multiplied by the integral from 0 this time around to r of the square root of r squared minus x squared dx. We are making progress. So this is what you need to integrate in order to get this formula pi r squared. But integrating square root of r squared minus x squared with respect to x is not that simple. Instead, let us make a kind of substitution here. We can substitute x with a function in terms of theta. Remember, cosine of this angle theta, let me write it here. Cosine of that angle theta is equal to adjacent divided by hypotenuse. Adjacent, which is x, divided by hypotenuse, which is r. So you can multiply both sides by r so that x will be equal to r cos theta. So instead of this particular x, we can replace it with r cos theta. But remember, our boundary, which is 0 to r, will have to change because initially we are dealing with a function in terms of x. But now substituting a function in terms of theta, even the boundaries will change. So dx, we need to find it here. If you differentiate x, you have dx. If you differentiate r cos theta, r is constant, so bring it back. Derivative of cos theta is negative sine theta, so you have minus sine theta right here. Minus sine theta, d theta. So now let us make a substitution. Our integral from where? From 0. Remember, you have 4 here. We have 4 here, which is this. So when x is 0, this is when x is 0. You have, let me work it out the other side for you to see everything. I don't want to miss anything. So if x is 0, you have 0 equal to r cos theta. So two things are multiplying each other, r and cos theta, and the result is 0. It's either r is 0 or cos theta is 0. But we know radius is not 0. Therefore, it implies that cos theta is equal to 0. So the question is, cos of which angle is 0? Definitely 90 degrees, which is pi over 2. So we have pi over 2 right here. Then what happens if x is r? That is the upper limit. It means that you have r here for x equal to r cos theta. And by dividing both sides by r, you have 1 equal to cos theta, right? So the question is, cos of which angle will give us 1? Cos of 0, definitely. that is from this point down here. Remember, we are in the first quadrant. All right, now we have the square root of r squared minus x squared. What happens if you square x? This is x. If you square that, you're going to get r squared cos squared theta. R squared cos squared theta. Then we have dx, and our dx is negative r sine theta multiplied by negative r sine theta. So now I would like to work out the whole of this square root by the side, then later we bring it back. What you should remember is we have r squared in common, so you can factor it out. You have r squared in bracket 1 minus cos squared theta. Yes, because r, we have factored our r from these two terms. Remember, they are all under square root. And 1 minus cos squared theta is simply sine squared theta. So this is r squared sine squared theta, also under square root. By taking square root of r squared, you have r. By taking square root of sine squared theta, you have sine theta, which implies that everything here is r sine theta times negative r sine theta, right? Which is going to give us what? Negative r squared sine squared theta. Because this is r sine theta, another r sine theta multiplying each other, we have negative r squared sine squared theta. So this is, that negative can be outside together with 4. We have from pi over 2 down to 0 of just r squared sine squared. Remember, we have d theta here, sorry. Sine squared theta d theta. All right. Now this negative 4, we can change it to positive 4 and flip the boundaries. Then pi over 2 will be up here and 0 will be down here. All right, let me come here. So the area is equal to 4. The integral from 0 to pi over 2. Now the 4 is now positive instead of being negative. And even the r squared, you can bring it out because it is a constant, right? So this is equal to 4 r squared. Inside we only have sine squared theta d theta. So this is what you need to integrate. And to integrate sine squared theta is not that simple. Instead, what you should remember is if you have cosine of 2 theta, this is cosine squared theta minus sine squared theta, right? But since we are looking for sine squared theta, which is here, we can write this one in terms of sine squared theta, which is 1 minus sine squared theta, right? Another minus sine squared theta. This is 1 minus 2 sine squared theta. And remember, the whole of this is equal to cos 2 theta. So you can bring this one backward. That is negative 2 sine squared theta, which is going to make it positive 2 sine squared theta equal to 1. Then you take cosine theta the other side. It becomes cosine 2 theta. Then you divide both sides by 2. If you divide both sides by 2, this is what you're going to have. So instead of this sine squared theta, you can now replace it with 1 minus cos 2 theta divided by 2. This is equal to 4r squared, right? Multiplied by the integral from 0 to pi over 2 of 1 minus cos 2 theta divided by 2 d theta. All right, we are progressing. Let us integrate. This is constant, so you don't have to integrate it. You can even factor it outside. The moment you factor it outside, it is going to divide this 4, and you're going to have 2r squared. Then inside, if you integrate 1, you're going to, with respect to theta, you're going to get theta. If you integrate cos 2 theta, you're going to get sine 2 theta divided by the derivative of 2 theta, which is 2. The boundary is from 0 to pi over 2. The last thing you need to do is to substitute the boundaries. Wherever you have theta, plug in pi over 2. After all, you minus the lower limit. But the lower limit will make everything equal to 0, because when theta is 0, this is 0. Sine of 2 times 0, which is sine 0, is also 0. So you don't have to substitute the lower limit. So this is equal to 2r squared multiplied by theta is pi over 2 minus 2 theta, that is 2 times pi over 2, which is simply pi, sine of pi over 2. And sine of pi is 0. Yes. So everything here will be 0. Minus 0, nothing there. We only have pi over 2 inside, multiplied by 2r. The 2's will cancel. We have r squared times pi, which is pi r squared. And hence, this is the area of a cycle, pi r squared. Thank you for watching. Do share to your learning colleagues. Bye-bye.